Hi, welcome. This is a lesson on graphing quadratic equations using the standard form. The standard form of a quadratic is f of x is equal to ax squared plus bx plus c. And remember that y equals f of x. So we could just as easily, instead of f of x here, put y equals ax squared plus bx plus c. The y-intercept is at the point 0, c. So just think, if I put a 0 here for x and a 0 here for x, if x equals 0, then these two terms just cancel, and y equals c. And so that's how that works. So the vertex, x equals negative b over 2a. We take the b value, negative, the opposite of that b value, and divide it by 2 times the coefficient a. And then we substitute this into your function to find the y value of the vertex. Now, the vertex of your parabola is the bottommost point. And so the x-coordinate of that is negative b over 2a. And then the y-coordinate, we sometimes say, is f of negative b over 2a. Or we take that, whatever value that is, and we put it into the function to see what the corresponding y value is. And we'll see this when we do some examples. The axis of symmetry is the line x equals negative b over 2a. And that would be the line of symmetry, which is the line that this parabola is not very pretty. Let's make it a little nicer. So there's our x and y axes. And this line right here, which I'm going to make a dotted line, is not technically part of the graph of the parabola, but it's the line that tells us that we've got points equidistant from that line on both sides. So if I know this point right here, I can figure out what this point over here is without very much difficulty, because let's say this is 2 units from the line of symmetry. I go 2 units over here with the same y value, and it would be another point on the graph. And that's true all along the way. All right. Direction of opening. This particular example right here is upward facing. And if A is positive, then it opens up. And if it's downward, if A is negative, then it opens downward, like in this example. Here A is less than 0, or A is negative, then it opens down. The maximum value, the y value of the vertex when the parabola opens down, is the maximum value, and the minimum value is the y value of the vertex when the parabola opens up. Domain, negative infinity to positive infinity. And the range, it says let k equal the y value of the vertex. And if the parabola opens up, then it goes from k up to positive infinity. And if it opens down, it goes from negative infinity up to k. It does have a bracket on k because k is included in both of those instances. All right, let's look at some examples here. Fill in the requested information for each function, then draw the graph. So looks like they have already drawn the graph for us on that one. That's nice. But let's figure out why we have those values. So first of all, there's nothing in front of my x squared, which is the same as saying that the a value is 1. B is negative 8. B is negative 8. And C is 7 because it's in standard form. So this opens up because A is 1, which is positive. So this opens up. The vertex is negative b over 2a. A is negative 8, so it's negative of negative 8 over 2 times 1. The negative of negative is positive. 8 divided by 2 is 4. And so the vertex, the x-coordinate of the vertex is 4. And then we take that 4 and we find the corresponding y value. So we put 4 in for x, which is 4 squared minus 8 times 4 plus 7. When you evaluate that, it comes out to be negative 9. So if we look at then this 4 and negative 9, we go over to 4 and down to negative 9, and that's our vertex. We know that it opens up. Since it opens up, it is a minimum. 4 negative 9 is a minimum. And so what is the maximum or minimum value in this case? It is a minimum. And the minimum value is y equals negative 9. The axis of symmetry is the x-coordinate of our vertex. And so let's use this blue line here. This is the line x equals 4. And so that's our axis of symmetry. The y-intercept, 0, 7. Where does that come from? Again, if I put a 0 in here for x, that cancels that. I put a 0 in here for that, cancels that. And then y, remember f of x is the same as y, equals 7. And so the y-intercept is at 0, c or 0, 7, which is right up here where it crosses the y-axis. And the domain of all quadratics is going to be from negative infinity to positive infinity. The range, because this is upward facing, starts down here at negative 9, and it goes up from there, all the way up to positive infinity. And so the range, or the set of y values, goes from negative 9 up to infinity. All right, let's look at the next page. At first glance, you might say, oh, that's not standard form. It is. Remember, we've got y equals ax squared plus bx plus c. And in this instance, we've got y equals negative 2x squared plus 4x. And then we don't have anything here for c. So I asked myself, what could I add on? What number would I add on to the end that would not change the value of anything? And that's true with anything. If I've got 3 plus some value equals 3, what do I add that wouldn't change the value any? And the answer is 0. And so I can put a 0 here, which means that a is negative 2, b is 4, it's positive 4, and then c is 0. And so our vertex is, once again, it's negative b over 2a. And, I'm sorry, I skipped direction of opening. The direction of opening, since a is negative 2, it opens down because a is negative 2. And since it is negative, then it opens down. And over here, vertex, negative b over 2a. Let's substitute in negative b. That'd be negative 4 over 2 times negative 2. That's the a value. So I've got negative 4 divided by, essentially negative 4. Negative divided by negative is positive 1. And then that's our x-coordinate. Sorry, I'm going to erase this. This is our x coordinate. And y then is, when we take that one value, we put it back into the original equation. Negative 2 times 1 squared plus 4 times 1. And then we evaluate. Negative 2 times 1 is negative 2. And 4 times 1 is 4. Negative 2 plus 4 is 2. So our vertex is the point 1, 2. So we can go over and start graphing this. We'll just go over here, 1, 2. That is going to be our vertex. And we know that it's going to open down. So I'm going to wait to graph anything else, but I know that it's going to be opening down like this. Is it a maximum or minimum point? Well, because it opens down, it's going to be a maximum. And what is the maximum value? Well, the maximum value is y equals 2. That's going to be the highest point on the graph. And the axis of symmetry. The axis of symmetry is always x equals the x value of the vertex. X equals 1. The y-intercept. Remember, it's 0, c. And we didn't initially have a c until we realized, oh, wait, c then is 0. So the y-intercept is 0, 0. And the domain is always from negative infinity to positive infinity. And the range, because it opens down, its lowest point, really there isn't one. It starts down negative infinity and then goes up to 2 and includes 2. So we put a bracket. Now we can go over here and start graphing this. I know that the place where it crosses the y-axis is at 0, 0. And I know the axis of symmetry again, axis of symmetry is not technically part of the graph, but it helps us to graph it, because I see here that this is 1 unit away from the axis of symmetry, so 1 unit on the other side, we have another point. And so then we can kind of sketch what this looks like. And then it's going to go down from there. On both sides here. And that's basically what this thing's going to look like. All right, let's look at C. This one's a little bit easier. It's already in standard form. There's nothing missing. We've got the 3 terms. So A is 3, B is -6, and C is -5. Direction of opening, A is positive. So it's going to open up. It's going to open up because A equals 3, and that's positive because 3 is positive, it opens up. If it was negative, it would open down, but it is positive. So vertex, x equals -b over 2a. B, that's -6, so that's negative of -6 over 2 times 3. And the negative of a negative is positive. So that's +6 divided by 2 times 3, which is also 6. 6 divided by 6, the vertex is at 1. And then we can say for the y-coordinate, y equals 3 times 1 squared minus 6 times 1 minus 5. And I'm going to do a little quick arithmetic here mentally. 1 squared is 1 times 3 is 3. Minus 1 times 6, that's -6, and minus 5. And 3 minus 6 is -3. -3 minus 5 would be -8. And so the vertex is the point 1, comma, negative 8. I'm going to go over here 1 down to negative 8, and I know that it opens up. Since it opens up, this is going to have a minimum point, and the minimum value is y equals negative 8. Axis of symmetry is x equals 1. The y-intercept is the point 0, comma, c, and c is negative 5, so it's 0, comma, negative 5. And the domain is always from negative infinity to positive infinity. And the range, because this opens up, is going to have a smallest point, and that smallest point is, as we've already said, negative 8 in y. Remember, the range is all of the y values. And the y value is going to go up from there, clear up to positive infinity. Now, we can start to graph this thing. What does it look like? Well, I know that it has an axis of symmetry of x equals 1, so I graph that. A dotted line is a good thing to do. Just kind of differentiates it from being actually part of the graph. It's not actually part of the graph of the equation, but it does help us to graph it. So then I put negative 5 down here as its y, the y-intercept. And since I know that it goes over here also, I can kind of sketch that part, try to make it kind of curvy even though they're really close together there. Parabola is always kind of U-shaped. It's hard to see the U sometimes and it looks just pointy, but it's always got a little U at the end there. And then we go up from there. It's just a sketch. And so those are the values. And that's all we've got. So practice, practice, practice. You'll be fine.